Welcome to Mining Now. I'm your host, Jared Downey. We've got Ziltek on the show today. We're filming it from IMARC. This is IMARC 2023 from Sydney, Australia. We're doing a lot of episodes across Australia, and the innovation, and just the drive coming out of Australia is just incredible. For us to be able to feature so many episodes has been awesome for the audience, and hopefully for the guests that were coming on, getting to share the leadership that is coming out of the mining sector in Australia. So we're going to have Dr. Sean Manning. He's the CEO of Ziltek, and we're just going to go through the company, some of their technology, where they're going, where they've been, bit of his story. Sean, welcome to the show.
Thanks for having me.
And I'm going to, the audience is seeing us looking like we're looking at each other. We're not. We're having some connection issues, so we've had to turn off all the cameras, and it's like a phone conversation. So just right off the bat, I appreciate you being flexible with us while we're trying to produce these episodes remotely.
It's no problem. I'm just pretending you're the camera.
Yeah, you suggested a wig on, so that's we need to get that. Okay, Sean, can you give us? I think I'd like to start with your background. Where do you come from, and how did that eventually lead to being the CEO of Ziltek?
Sure. So, born and bred in Adelaide. I studied physics. I did my undergraduate degree at Flinders University. Got really interested in the experimental side of physics. I then moved on to Adelaide Uni because they had a really active optical physics research program. There was better postgraduate opportunities there. So I did my honours degree at Adelaide Uni, went on to do a PhD, and then following that, realised that the academic life really wasn't for me. Short-term contracts, constantly hustling for that next grant. So I decided to go work for the government. I worked for the Department of Defence for a number of years. Did some very interesting work there around laser communications and sending laser beams through the atmosphere and even up into space. Ultimately, I didn't love the environment within government. There was a lot of perverse incentives and a lot of friction to getting things done. And so I started looking around for work elsewhere, and an opportunity came up at Ziltek to slot into the chief scientist role. Ziltek were doing some really interesting things, utilizing spectroscopy and the way that light interacts with matter to predict the properties of soils. And they hired me. I spent 3 years in the role of the chief scientific officer. And then at a point in the company's history, it was decided, we had two products at the time, very, very different types of products. And so the decision was made to split out those two companies. The managing director went on to head the other company called RemBind, and I was promoted up to CEO of Ziltek.
Oh, okay. Okay, that's a very good summary. I think I'm going to have to back up on a couple of those things.
Sure.
So, actually, something that came to my mind when you were saying about just harder to get things done in that government role, it's something that summarize, it sounds a little bit bogged down, which is sort of typical for the government environment. But coming into that, now going into the private sector, what did you take from that? I mean, governments, they have systems and they run things in a certain way. Were you able to take any of that experience and then apply it to this role now?
Look, I learned a lot. Working for defense, I honed a lot of skills. But really, the main thing I learned was that I like an environment where the rubber is hitting the road all the time. You can toil away as a government researcher working on things that may never be useful, and that's a very important function for research because you can't always anticipate how things are going to turn out, and you have to do this blue sky kind of stuff. But ultimately, you exist whether you're producing results or not, whereas in the private industry, results really matter. And I like that pressure.
When did you realize?
Maybe I'm a glutton for punishment.
Right. Did you? How far into it did you realize? No, I need that pressure.
I think I was there for 6 years. Probably about year 3.
Right, I was going to say, I would make it about 3 years. I think I could do it 3 years.
Yeah.
And then I would be looking over the fence.
It took a while to get out. I needed to find the right fit for myself. I wasn't really sure exactly what I wanted to do. And you're also waiting for the right opportunity to come along as well.
Let's talk about our Heavy Industry World Tour brought to you by Savannah Equipment, supplying mining equipment worldwide, and Geograph, solving customer challenges through innovation and design, higher performing parts, engineered solutions, on-time spare parts supply, and high-quality repairs. We are heading to events across North America, Africa, and Australia, and filming episodes on location. Email us at info@crownsman.com to be part of Crownsman's Heavy Industry World Tour. Revolutionize your mining operations with MassPro's engineering excellence. Their engineering talent can transform your mining machinery, supercharge your productivity, and improve your equipment optimization. Your success is their mission, and they're prepared to take your mining operations to new heights by maximizing efficiency, safety, and ore extraction like never before. Head to masspro.com.au for further information. Bentech Group is an industry leader when it comes to design, engineering, and manufacturing. Bentech specializes in engineered safety and efficiency equipment such as access platforms, heavy-duty workbenches, work stands and trestles, material and equipment storage, and a range of lifting and handling solutions to maximize safety for your personnel. But that's not their only area of expertise. Bentech also supply high-performance OEM replacement parts for mobile equipment. Bentech's rocks mining parts are built better, eliminating downtime and maximizing efficiency. Visit bentechgroup.com.au today to explore their range. Solving the complexities of operational efficiency, safety and compliance, and asset management in mining can be a significant headache. Madison Technologies understands these challenges, and with over 3 decades of industrial communications experience, they're not just a supplier, but a transformative partner in digitization. Madison Technologies accelerates the digital journey of their clients, and together with global technology vendors, they deliver practical, real-world solutions. Visit madison.tech to discover how they can help you unlock future potential with Mining 4.0 solutions.
What about Ziltek before you joined? What about them made you think this could be good for me?
I mean, at heart, it's a really smart idea. It's a really great utilization of a fundamental technology that I had a fair bit of experience with previously, but more in a lab setting, in a basic science setting. So in my PhD, I made a lot of glass, when people say glass, they often think the window, but these were sort of experimental glasses made out of fairly exotic materials. And in making a material, you have to characterize it, right? So we're putting it in lots of machines and measuring lots of its properties. And spectroscopy, the way light interacts with matter, is a huge part of that, especially because the materials I'm making were optical materials. They were designed for light to go through them and to do cool things with them. And so I had a background in spectroscopy in a very sort of academic sense, and I really liked what Ziltek were doing in terms of taking that sort of very research-based tool and actually making it really practical for basically anyone to use, and putting it in the hands of, in many cases, fairly unskilled operators. They don't need a PhD to sort of interpret data and any of that kind of stuff. They just pull a trigger and get a number. And the way you get that to work is by putting a lot of smarts into the software that essentially replace the PhD who would normally sit in a lab and crunch data.
I want to unpack some of especially the software side, but before we do that, what is the Ziltek story? How did they get founded? What problem were they solving right from the beginning?
Sure. So Ziltek started in about 2008, and the founder, Dr. Richard Stewart, he became aware of some very great research that had come out of CSIRO around using mid-infrared spectroscopy to determine how much oil is in contaminated soils. And the key thing is there that the alternative ways of doing that are a bit cumbersome, and they take a long time. It involves extracting the oil from the soil using solvents and then running that through other equipment, whereas you can literally almost point and shoot and get a result of the same quality. So Richard grabbed that IP, licensed it, and then commercialized it into the product that we now call RemScan. That took a few years and a lot of really hard work, but when I joined, that product was fairly mature, and they'd already had some good market uptake, and it was then time to sort of really refine a lot of the technology, but in particular the processes around the technology. And I just saw, I had my interview there. I saw great opportunities, a lot of a lot of room for me to be innovative, and also there was that really real aspect of it, that is, we're making this tool for people to use in industry. They're making important decisions based on the results that it gives you. So it's a very real application of measurement technology.
Orica Digital Solutions seamlessly connects customers' physical and digital worlds so they can readily understand and optimize operations at every step of the value chain, from exploration to processing. Whether deployed individually or as a whole, Orica Digital Solutions technologies deliver intelligence for open cut and underground mines to make more precise and faster decisions. With a complete, timely, and accurate picture, operations can adapt to improve safety, drive productivity, reduce costs, and environmental impacts. To learn more about Orica Digital Solutions, visit orica.com/digital solutions today. If you're treating refractory gold or complex ores, then you need how to leach difficulty or varying feeds and recover more. It's packed with cases and papers on Albion process leaching technology, but it also has the world's first online calculator. It's free, and you'll learn what CapEx and OpEx you'll need for Albion process to treat your feed. You need Albion process to liberate your refractory locked gold. To get your pack and use the free calculator, click the link in the description below. Okay, so let's give a special thank you to one of our longest sponsors of the show, Savona Equipment. And I'm actually going to hand it over to Jared so that he can give you a little bit more info on Savona Equipment.
Yeah, thank you. So I mean, people see them as sponsors, so they'll ask me, kind of who they are, what they are, and just trying to understand the scope of the company. So Savona Equipment is a mining supply company, and they're delivering on the whole equipment supply chain. So everything from the ore processing to underground mining, open pit. They're in hard rock and placer operations. And what they're doing is they're sourcing equipment from all over the world and then delivering it all over the world. Now, they are a Canadian company, so they're based there, but, let's say, they're selling entire ore processing plants. So there might be a plant down in Latin America, and there's a new mine that needs that plant in Africa or somewhere in the US. So they're facilitating that entire transactions. But they're also delivering, an individual conveyor or a concentrator or a pump package or just an electrical package. So it really is the whole gambit of the mining equipment supply chain.
Oh, that's great then. Well, then you definitely have to check them out if you're looking for mining equipment. Visit them at savonaequipment.com, where you will find more equipment every day.
I've learned doing a lot of these interviews that by doing comparison, you can really bring to light you can really communicate to an audience what you're accomplishing now. So when you say refine, when you came in, these processes needed to be refined, or the technology needed to be refined. What needed to be improved? Where was the next step that had to happen? And then, of course, we'll pivot into where it is now.
So a lot of what we do with the instrument is what we call calibration. So loosely speaking, that means we're teaching it how to recognize the properties of various soils. And there's a process around that, from the very beginning of what samples do you use to train it up, how do you prepare those samples, then once you have the prepared samples, you gather data from them, and then there's a whole heap of steps of essentially building mathematical models that map the raw data that the machine acquires to a result, to a single number, for example, how much oil is in the soil. So those processes were very human intensive. There was a lot of crunching of numbers and iterative steps. And one of my contributions early on was to really refine that process to the point where 90% of the time it's automated.
Oh, I see. So what did that take? Can you walk us through it? Just even develop for a lot of people listening and someone like myself, I can't even understand the process that it takes to make that happen.
Yeah, it's very application specific, but the main thing is around firstly finding what works, right? So you have many examples that you've done in the past. You can identify what aspects of those worked well, what aspects didn't. So you sort of strip back the process, so it's only the good parts, and then a lot of the processes are essentially data treatment or processing steps, and you can sit there looking at an Excel spreadsheet, filling out columns and writing in formulas, or you can go to a more programming basis. Use Python, set up data structures, and standardized data processing routines. So there's many ways to treat the data. You have to find the ones that work best. You use real data to make those decisions on. Otherwise, you sort of just go around in circles. So there's a lot of process optimization, but eventually you end up with a very stripped down, simple process that can be handled more or less by a computer. And then the human is there as the overseer. So we'll set up flags, for example, when things aren't going quite to plan, or there might be problems in the inputted data that we can spot, and then a human will go in and deal with that. But like I said, 90% of the time we ingest the data, it crunches away, and it spits out our calibration model, which then we upload to the client's instrument, and off they go. They can measure.
It's amazing how, I mean, and I'm one of the people that uses all these types of devices and data, and I just go, oh, that's really easy to use, without realizing what it actually took manually a lot of times to put all that. How long did that process take to get it to that 90%?
It's a good question. Probably a good couple of years. I mean, to be honest, when I started, there was a very steep learning curve. I had to get my head across all the processes and the technology and what had been done in the past. I'd say for the first year, I was sprinting to catch up. But once I did, and I was able to sort of take a little bit more time, I was able to start looking at how we were doing things and simplifying them and codifying them into scripts, basically, so you can just data in, results out, provided you build in the appropriate checks and balances so that you're not just, as they say, crap in, crap out. Right? You got to be really careful.
Yeah, I know people who are actually even studying it right now, like data analysis, and it's. So I'm trying to learn to be able to at least discuss it so I can understand, and it's quite something. It is like a different language. I want to get into, can we talk a little bit of real-world application as well, though? Because sure. RemScan has done, it's kind of been all over the world. Can you walk us through, some oil projects, mining? I know it's been in, like, I think Kuwait and Indonesia. Mm-hmm. Can you walk us through some of the places where it's applicable, what it was doing at those specific locations?
Absolutely. So at its heart, what we're doing is we're telling our customers, or the instrument is telling our customers, how much oil is in the contaminated soils. What they want to do with that information is make decisions on the ground about how to treat the soil. So, for example, you have a spill, you don't necessarily know the full extent of it, so you need to do what's called delineation, which is basically working out where the spill is. Sometimes it's obvious, you can kind of see it or you can smell it, but there becomes a point where your human senses run out of room, and then you need to rely on some sort of technology. So, at a very basic level, you can use it for determining where the extent of the spill is. So once you've done that, often what needs to be done is that earth needs to be excavated and taken off somewhere to be treated. As you're excavating it, you want to be sure that you got all of the contaminated soil and you didn't leave some behind, so you can use the instrument to get that information. The alternative is to put soil in jars, send them to labs. The labs do the extractions and the measurements, and then if you're lucky, in a few days or maybe a few weeks, you get the result back. So you can really see how that would hold up processes on the ground. So we allow people to really shorten the time frames of their works, because they've got the information where they need it. Once you've then removed all the soil, excavated it, you maybe put it on a pile. A really common way to remediate soil is what's called bioremediation, where you essentially use bacteria in the soil to digest the oil. It takes a long time, it's a slow process, but it needs to be monitored as well, because the bacteria can die, they can run out of some of the nutrients they require, and that process can stall. So people who are doing bioremediation also need to monitor that process and track it as it's remediated over time. And again, the alternative is you're pulling jars of soil and you're sending them to labs and you're waiting for the turnaround. The other aspect of that's often mislooked is when you do have to put soils in jar, and you do have to send it to the lab, and you do have to pay for the lab expense, there's a downwards pressure on how many samples you actually take. And so frequently people are operating with minimal information, and that makes the certainty in their decisions, it increases the uncertainty of their decisions. So not only do we provide measurements on the spot, and they're very inexpensive, you can just scan to your heart's content, which means that you can make more measurements than you normally would, and you can increase the certainty of your decisions.
Going to market with this, how quickly did the market react when it went full scale? And I don't know if you were involved in the company when it was already fully to market. Was that the case when you joined already?
It is, yeah. We'd already had the early successes from the basically early adopters, companies and individuals who are willing to take a chance and do something different. Often there was a lot of collaborative aspects to those relationships where we would prove the technology to them, and they would also work out how to adapt their practices to accommodate this new way of doing things. That was really foundational for the company because, we learnt, I think, as much as our customers were learning. And now we are very clear on what the value proposition is, how to use it. We provide lots of advice to our customers on how to get the most out of it. And so now it's a matter of finding the need and supplying the equipment to the customers.
Something I've been doing on this show recently is I realized that there's probably people watching that are going, I need to know this. So I ask all these questions just from my own point of view, and then I miss them. So I'm wondering, what are some common, maybe it's 2 or 3 really common questions that you get from, and I mean serious clients, people that need your product, thinking about onboarding it, and it's part of the discussion. What are 3 main questions that they're asking you?
Yeah, so usually people want to know, firstly, how does it work? A lot of people don't want to just buy a black box, a magic machine. They want to know actually what's going on inside of it. They want to know how they need to adapt their practices to utilize it because it is doing old things in a new way. So, we'll talk them through that. And the main one they're interested in is how accurate is it when they compare it to laboratory measurements? Or, is it going to line up? And the decisions they're making based on the numbers it gives, are these good decisions, or is it a random number generator and we're making things worse?
So, and that's actually something I wanted to bring up is, well, one, how disruptive is this to the market? You're talking about putting things in glass jars. So, I mean, it's kind of night and day difference, right?
Yeah, it is quite different. We find that most of our customers so far, it's almost been forced on them by the nature of the job, right? So we're talking about massive remediation projects that are requiring not tens of samples, but like thousands of samples. And people were looking at the numbers going, we are going to bankrupt ourselves if we have to send these to the lab. Also, the operations are going to go on indefinitely because we're just going to oversubscribe the lab. We're going to wait for the turnaround times on all these things. So it's almost... in some of these cases, I don't think the projects would necessarily go ahead if they didn't have access to this field measurement technology.
Do you then find, though, that sometimes because it's such a difference, and I quite often wonder this with disruptive technologies, that it's almost hard for people to wrap their mind around because they've been doing it this way so long to then go, okay, we're just losing this entire cost. I mean, this is in their budget. They thought they were going to have to spend this.
Yeah, that's right. And we find that the smaller projects are the ones where we really get stuck on because people are used to putting 5 or 6 samples in jars, sending them off, getting the results back in a few days' time, and then deciding what they're going to do about it. And so that's whereas what we're saying is you can go out there, get your results, decide that day, and then act. They're completely different ways of doing things, and so yeah, there is a hurdle in getting people to change their practices, especially some people are older and more set in their ways. They know how to do things, or they think they know how to do things, and getting that behavior change is quite hard. So we tend to get a lot of traction with younger companies or people looking to be more innovative, and again, like I said, huge jobs where it's just financially inconceivable that you could send this many samples to the lab and remediate like that.
Right. If you go through a list and because I saw a list that was sent to me, how do you sort of go through all the values? You've touched on some of them today, but what's sort of the list of the different values you're offering to your clients?
So the main one is results immediate. Okay, you want to ask the question, how contaminated is this piece of soil? You can find that out in tens of seconds. So they're saving time, on waiting for the results. They're also saving money on the lab analysis fees. I think another real value add that we have is our support and our service. Things don't always go to plan. Sometimes you have strange results, and I think something that we do really well is to support all of our customers. They can come to us basically night or day and say, look, I'm getting weird results here. I don't quite understand what's going on. We say, send us the data. We have a look at it, and we can frequently turn that around overnight for most of our customers because they're in other parts of the world, and get back to them with results. So it's the RemScan value is more than just the information that the machine gives you and the timeliness that it gives it to you in, but it's backed up by some really comprehensive customer support for those weird cases that they're going to arise inevitably, and we're there to help people through them.
What about What about the data? Where is this? Is the data going to the machine? Is it through cloud systems? And I'm sort of alluding also to the protection of the data as well.
Yeah, that's a really great question. So early on in the company's history, as the product was being shaped through feedback from some of our early adopter customers, one of the requirements we had was that the data be in a secure database. So essentially what happens when you make a scan, firstly, there's no requirement for people to save data. It's instantly saved the second you make the scan. So you can't, inadvertently not save a day's worth of data and throw away all that work. It's saved instantly in a database that the customer does not have direct access to. If they want to get the data out, there's an extraction process where they can export it, and they can get Excel spreadsheets showing all the results, and we share the raw data, the whole lot. The point is that the basic database cannot be touched, and so that makes it really, you can audit the system. This requirement was there so that people couldn't change numbers. It just happens that in certain parts of the world there are, there can be. I have to be quite careful with how I frame this, but
everybody already knows what you're getting at.
Okay, all right. Sometimes people aren't honest, and organization needs to protect themselves from that kind of behavior, especially when you're talking about remediating land. Like at the end of that project, your company's going to walk away from that and say, this is now clean and fit for growing crops on, or human habitation or something like that. And if that's wrong, there are some dire consequences. So the data is sacred, and the base data, the database that lives on the tablet, cannot be manipulated by anyone but us. We don't manipulate it. We just
but that includes the user. That includes someone out on the field. They can't tamper. Essentially, is what you're getting at.
Absolutely, that's right. That's right.
The other thing I was thinking of, maybe this isn't as big of a deal as that came to my mind, but if there is, sometimes you'll see something go wrong, and then it seems like as you're fixing it, it's like you're seeing machines coming in, and it seems like, would this sort of minimize almost further disruption? Like if they're having to dig up stuff, and that you're probably minimizing the amount of even the shifting around of soils and samples. And you're kind of minimizing all
that's
that,
right? Yeah, so say you're excavating some contaminated soil and you want to get all of the soil, but you're also paying for the excavator's time, you're paying for the soil trucks to move it out. And so if you don't have good information on the ground, what are you going to do? You want to be sure that you got it all, so you'll probably over-excavate, right? And therefore you're moving dirt you didn't need to move, you're using people's time that didn't need to be used. So you can be a lot more precise about where you call it. So that's a definite advantage to the technology. It takes the guesswork out of it, essentially. Likewise, it can go the other way. If you under-excavate and you leave behind some contaminated soils, you think you're done, you pack up, and then you get a lab result back. So all of these projects, the final sign-off is from a laboratory measurement. It's just that our users are very confident on what results are going to come back when they send those final samples off to the lab. If you didn't have that confidence, you get the samples back. You've already, taken all the plant away from the site. You get those samples back, and actually there's still contaminated soil there. You got to remobilize, and that can cost a lot of money.
Sean, can we just talk a little bit what future technologies, R&D, innovation, sort of outward-looking or forward-looking, I should say, what does that look like for Ziltek?
Yeah, really exciting. So what we have, like essentially our technology is a platform technology. Really, all the instrument does at its base level is collect a chemical fingerprint of the sample that it's looking at. So we realized, a few years ago that we're kind of nailing this oil and soil thing. We're really good with soils generally. What else could we do with the platform? What other industries could we get involved with? And it was, kind of obvious. We're already working with soil. Why don't we look at agriculture? So we started talking to agronomists and farmers about the kinds of things that they want to know about the soil, as well as labs, discussing, what they actually measure and so on, and getting a sense for is there a need, right? We only want to move into industries where we can have an impact, where there's a need. The feedback was that it would be really useful to be able to know on the spot some of the soil properties, in a paddock, right? Like, why is this area growing well and this one isn't? What is the difference? They look the same to the eye. Maybe there's something fundamentally different about the soils that we can't see. And while we were going through that, we keep hearing about soil carbon. And this is really an offshoot from agriculture, no pun intended, where, yes, there are agronomic benefits to having carbon in the soil, but if you can increase how much carbon you have in your soil, that means you've taken it out of the atmosphere. So there's an opportunity for so-called soil carbon sequestration, where what a landowner needs to do is firstly establish how much carbon they have in the soil to get a baseline, and then they change their land management practices in one of a number of ways, and it really determines on what they're doing there and so on. There's a whole heap of things you can do, but the objective is to increase the influx of carbon into the soil and keep it there. And if you do that, and you can quantify how much carbon dioxide you took out of the atmosphere, you can get carbon credits. You can get paid for it. The issue in that industry at the moment is that it's quite expensive to establish that baseline and to do the follow-up tests. Right. The federal government have been funding soil carbon innovation challenges, looking at ways to decrease the cost of soil carbon measurement so that more people can enter the market, and so that the carbon credits become more valuable, that they cost you less to get involved in the process. So we've won one of those grants, and we're involved with another one with the University of Queensland, where we've been able to, in the initial stages, prove to ourselves that the technology can do what we want it to do, and work out some of the hows by actually getting out into the field and making the measurements ourselves. And the later project is really around calibrating our instrument for all of the Australian soils. So we're currently working our way through what will be 15,500 samples, carefully selected from farms all around the country in every state. And we're ingesting that data into our system. We've got people scanning basically every day as the samples come in, and we're training it up so it can accurately quantify carbon in Australian soils. And based on that model, we know how we can expand that to be global.
Well, I was going to say these things, Canada for sure, but the U.S., that there would be a huge demand, I would think, especially in the U.S.-Canadian market for this.
Yeah, even Southeast Asia, countries like Malaysia are very on the front foot on a lot of this. But essentially anywhere where there's a lot of agriculture, and there has been for a long time, there's a tremendous opportunities to take a lot of carbon dioxide out of the atmosphere and get it into the soil. And it's really a dual benefit, because yes, you've helped take some of the carbon out of the atmosphere. That's very important. But also, generally speaking, it makes the soil more fertile, and importantly, it holds onto water more. So when you go through a drought period, you'll suffer less if you have more carbon in the soil. So there's a lot of benefits to increasing the amount of carbon in the soil, just beyond carbon credits and the financial side of things.
I want to wrap up with two topics. Is one, expansion. A lot of companies that come on from Australia, they're pushing. We have a big audience in the U.S. and Canada, Australia as well. But the U.S. is the largest. How do you approach that essentially global expansion of a company? How are you approaching it now?
To be fair, we've been very passive in our marketing. We're a needs-based product, right? No one's going to buy it unless they have a problem to solve. And so essentially there will be some contaminated soil somewhere. somebody's on the hook to have to remediate it. Then they start looking around for tools and technologies that they can use to facilitate that. And that's usually the point where we'll make contact with the prospective customer. They generally find us through our website, and then we'll start a dialogue. They'll say, hey, your equipment looks cool, looks interesting. We'll set up an online chat. So we've actually invested quite a bit of money in a streaming studio so that we can do high quality product demonstrations, and we use it for our training and all sorts of things like that. So we'll start this relationship. There's a lot of back and forth. We'll usually talk to people at a fairly technical level, environmental engineers or people like that. And so we can have a fairly high-level discussion about how things work. They generally understand the lab processes and all those methods as well. We reach an understanding where they know what it's going to do for them and how it's going to work. And then if they're still interested in going forward, then we go down the sales process.
What about like educational like institutions? Are you collaborating? Do you collaborate at all with them, either for the education part or for like R&D, things like that?
Yeah, absolutely. We have a few universities who own our technology. A notable one to mention would be RMIT. They use it, so they have a really active program both in research and in teaching for environmental management of environmental engineering, and they do a lot of research on bioremediation. And for those guys, it's actually a really analogous use case. They're an academic institution. A lot of these are, teaching programs. They're not super well-resourced in terms of funds. So if every student doing their project on bioremediation had to send samples to the lab, you got the same problem. You got the turnaround times. They right. So we actually have, or RMIT actually have students who do these bioremediation projects in like teaching labs, and they're able to make a whole heap of measurements, in the span of a university laboratory session. Just would not be possible with the standard way of doing things. And RMIT have been really instrumental in proving that the technology works very well for monitoring bioremediation, because not only are their students doing it, but they're doing it at a research level as well.
I was thinking that'll be a future marketing tool, because those students are going to go into the workforce and they're going to be putting those samples in jars. And they're going to go up to their boss and say, "This is ridiculous. What are we doing?"
Exactly. Yeah, that's the hope, right? That's the long game.
Before I let you go, I want to ask. You start as a CEO as a company, and we talk a lot about leadership and that. But some of the things that interest me as well are just the day to day. And do you remember the first day you got the job as the CEO? You got promoted to that position, and it's day one. Do you still remember that?
Well, it was New Year's Day. So.
Well, that might be a reason you don't remember it, actually.
Oh, no.
Okay.
My heavy drinking days are well behind me.
Okay. But what was, it doesn't have to be the first day, but the first week, the first month, sort of absorbing that, and now you're in this position where you have to you have to enable other people, you have to drive the vision of the company forward, you have to find sometimes a new vision and expansion and marketing, and a kind of away you go. What was that first period like, bringing on this position?
It was a steep learning curve, because there was a lot of administrative things that I hadn't gotten my hands dirty with up until that point. But in terms of the other things you mentioned, like the vision for the technology and the company, I was already very clear on that before the role, and I think that was, a large part of what made me suitable for it. And me and the former managing director were very aligned on where we think the technology can go in the future. So from that point of view, it was a very smooth transition. I'd been managing, some of the people underneath me, that then shifted up to being more people. I enjoy that aspect of it. It's funny. Back in my uni days, I used to say to myself, I never want to get into management. That's the death of a scientist and all this kind of silly thing. But I find I actually really, really enjoy the people management side of things, and maybe that's just because I have an exceptional team. But I've really enjoyed it. I think the biggest challenge for me, though, is stepping back from the technical work. I love it so much. I've spent a lot of time being, up to my buried in it. and I had to essentially replace myself with a new hire and pass on knowledge, and then have the willpower to step back and distance myself from some of the nitty-gritty technical work that then has to be handed on. That was probably the hardest thing for me, I think.
Yeah, that I think if you love the technical work, I don't think that ever stops. But what came to my mind is I think Elon Musk brought it back being cool. Being really involved in the tech, sleeping on the assembly line and all these crazy stories. Because for a long time, I do remember there was a big trend of all the management seemed to be about not working in your business, work on it, and all that sort of stuff. That was a big push. There was a lot of it. And I think somewhere in the middle is actually, this is just my opinion, I think it's somewhere in the middle is good ground, where you need to know when to step away, but you also have to be willing to sort of get your hands dirty with your team and learn the technical, because those are part of the process. Those are little details that actually help you grow your company and stay efficient. I don't know what your thoughts on it, but that's sort of where I landed.
They're aligned with yours. I can't comprehend running a company, especially a technology company, where you don't have a deep understanding of the technology itself. I just don't know how you would do it. And I completely agree. The Elon Musk idea. He's got a lot of great things with how he runs these companies. For example, having the designers and the engineers working together, so you don't have these siloed departments that are sort of almost working like parallel and never meeting.
Sometimes against each other.
Pardon?
Sometimes against each other.
Yeah, absolutely. So I take a lot of lessons from him and people like him in how you do it. We benefit from the fact that we are a small company, so whether we like it or not, we do work across different areas, and there's a lot of overlap in what we do. But I think even at scale, I just do it the same way. Everyone in the company needs to understand the product. I have someone doing digital marketing, and they've been trained on how to use the instrument. How can you make, instruction manuals and quick start guides and so on if you don't know how to push the buttons on the device?
Or even a LinkedIn post. You can tell when someone understands. A company, you can go onto a company's page and go, oh, their people know. Like you kind of make an assumption that on a LinkedIn post, it's probably a marketing person putting it up. And you can tell the difference when someone understands the actual language. And I don't even know how to tangibly tell, but you can just tell.
It has an authenticity to it, I think, that you can't fake.
Yeah. What was I going to... Oh, before I let you go, the last question I have for you, and I promise this is the last one because I know you're at a show trying to promote. But... how do people get the product? So is it like globally? Do they deal directly with you? Do you have distributors? What's the model?
Yeah, it depends where in the world you are. So if you go to our website, you can see that we have distributors in certain key regions, notably Southeast Asia, Middle East, North Africa, and Europe. But so depending on where you are, I mean, a lot of the inquiries come directly to us via our website. And if it does come from a region where we have a distributor, we very quickly just pass them over to the distributor. But largely speaking, you come to us through one of a few channels, and like I said, there's a bit of a courting process where we get to know each other, what the needs of the customer are, what we offer, and we try to see if it matches. Sometimes people have expectations that we just can't meet, and sometimes they have problems that we can solve very easily. So we try to filter that out very quickly. A really good example is our device. We say it's for hydrocarbons. It can detect petrol in soil, but like gasoline. But the problem with gasoline is that it's very, very volatile. So it's literally leaving the sample while you are measuring it. So you can't get a stable measure of it. Putting that sample in the jar and capturing all those volatiles and sending it to the lab still has a lot of benefits for gasoline. And so when we get inquiries from companies who are solely focused on remediating gasoline, we usually steer them towards competing technologies because we know we're not going to be the best fit for them, and we don't want to waste people's time and money.
Well, that also is a sign of a good company. Sean, I really do thank you for coming on the show. This, and I keep saying it, and I'm sorry the audience but Australia just has. I've asked Australian guests what's driving all the innovation and the entrepreneurship. And I will say specifically out of Canada, I just heard on our on the radio, actually, from our broadcasting, our national broadcasting company, that entrepreneurship is down. Now I can't remember the number, but it's a huge drop in Canada specifically. And talking to all these companies in Australia, it seems to just be on the rise. Is it just sort of part of the culture, or do we just have to be talking to the companies that are really pushing new technology?
I'm not really sure. It's a really interesting question. I know Australia has suffered a lot from our cultural attitudes about failure in the past. So I know in the US, it's the very different attitude about failure. You know, you start a business, it fails. Hey, great job. Maybe your next one will succeed, right? Like it's not like a black mark against your name. Whereas for many years in Australia, I think it has people have been unwilling to take that risk because they don't want to fail. So maybe we're importing maybe a few more values from the US and being a little bit more cool with risk. That could be a part of it. I know the government has been stimulating R&D and a lot through tax breaks and funding programs and so on. So I don't know. I think there's a lot of forces interacting. It's also very cool to have a startup these days. I mean, it's almost a fad in some places.
Yeah, it's just interesting. And again, I don't know. It's just from my experience. I find here we're doing a lot of. This the innovation. It's just a bit of a different approach, and it just seems every time we come and deal with Australia, it just seems to ramp up more and more. So either way, it's very exciting. It's a lot of fun to be a part of. So we're going to put links to Ziltek, even your own LinkedIn if people want to connect with you directly. Sean, thanks for coming on the show. It's lots of fun. I hope you have a good event at IMARC, and that maybe if you're in Canada, we'll do an in studio or something, because it would be great to have you back on.
I love Canada. I can't wait.
Okay, thank you, Sean. Talk soon.
Cheers.
Okay, that's the episode for today, everybody. Again, we will put a link to Ziltek's LinkedIn, so you can follow them. I don't know if they did. I should have looked to see if they have a YouTube channel, but certainly their Facebook as well, their website. You can connect with Sean on LinkedIn. Please do all that. Please follow us. Thank you for watching. We'll see you on the next episode of Mining Now.